All right, so yeah, we're good. All right, so yeah, so let me just read this. So a boy claims that he wears darker colored clothes, that when he wears darker colored clothes, he feels hotter. He further claims he can arrange 5 of his shirts in the order of hottest to coolest. He,
Sir, sir, let's go there, sir. We have this.
all right, so this is called a um a P&D lab. What is this? Oh, this is called a plan and design lab. All right, so let me just finish read and then I explain. All right. So a boy claims that he wears darker colored clothes. That when he wears darker colored clothes, he feels hotter. He further claims he can arrange 5 of his shirts in the order of hottest to coolest. He then makes an arrangement of black, red, orange, green, and white. Plan and design and experiment if the boy's order of arrangement is correct for the absorption of heat. Now, this type of lab is called a planning and designing. All right, so this is called a planning and design lab, or a P&D. So essentially, you are going to go ahead and use this problem to and come up with a possible solution. But before you can say that, okay, this solution makes sense, you have to go ahead and plan the lab first. Now, a part of this lab, you have a mark for the hypothesis. So the hypothesis right, is a prediction. A hypothesis is a prediction of the solution to the problem. So let's start at the first one. Let's read it over again. So a boy claims that he wears darker colored clothes, that when he wears darker colored clothes, he feels hotter. He further claims he can arrange 5 of his shirts in order of hottest to coldest, right? He then makes an arrangement of black, red, orange, green, and white. Plan and design an experiment to determine if the boy's order of arrangement is correct for the absorption of heat, right? So his arrangement, he said from hottest to coolest. So he has black, then red, then orange, then green, then white. What do we see about these colors? Do they get darker or do they get lighter?
We get lighter, sir.
Exactly.
Come get lighter.
Exactly. So they go from black, red, orange, green, and white, right? Now, for your hypothesis, you would say, all right, you would say that you would provide a solution. So is the aim of this experiment. Let's just say we should plan an experiment to determine if the boy's order of arrangement is correct for the absorption of heat. So is this correct or is this not correct? Going from hottest to coldest. Is it correct?
Oh, yes, sir. Yes, sir.
Well, cool.
We're going from hottest to coolest.
Yes, sir.
It is correct.
Yes, sir.
All right.
Yes, sir.
Why is it correct?
Because they start with a black shirt and black heat.
Exactly. So black absorb the most heat,
And with a
and
white shirt and it reflects heat.
then white has the less heat. So your hypothesis would be a prediction of the solution, right? So you would be predicting that this is correct or this is incorrect. Now, in order for you to do that, you'd have to state a method that you would use to predict this. So how would you go about determine if this is true?
Get volunteers to wear shirts.
All right, so you get volunteers to wear shirts, and what would be the next step?
Make them walk up and down that sun.
So I knew that was coming, right?
Observe.
But you said volunteers. Which volunteer would really walk up and down the sun voluntarily?
My classmate.
Sir,
All right.
observe them for days, sir. Jesus.
Oven.
I didn't hear that.
Observe them for days.
So observe persons walking up and down in the sun for a day. Wow. So
I just leave it.
exactly. You can just leave it in the sun. Why would you be so cruel? All right, so we would I would nominate Mr. Dean to walk up and down in the sun and we observe him. All right. I would nominate Mr. Dean. Anyone else votes Mr. Dean to walk up and down in the sun?
I second it.
Alright. Alright, so we could simply leave the shirts in the sun. So you leave them, and then it is up to you. You don't have to tell me, right? It is up to you how long you would leave these in the sun. So don't tell me. Don't tell me. You plan and design that for yourself. I'm just guiding you, right? So you would tell me, you would state in your lab how long you would leave the shirts in the sun. You can leave them in there for a week. You can leave them in there for a month. You can leave them in there for 5 minutes, right? You can leave them in there for, that is unique to you. That is your planning. I'm just guiding you as to the correct way to care about this, right? So how would you determine which one is hottest, or which one is the coldest?
Depends on the type of material to make the shirt.
All right, so we would have to, right? We're changing the color. That's a good point, right? We're changing the color of the shirts. Are we changing the material of the shirts? Are we looking to see which material is the hottest or the coldest? Is that what we're looking for? No. So we're not thinking about material. No material. All right. So the material stays the same. So he's in the same. All right. Let me just. What does that say? No material. So the material of the shirt. Come on. Material of the shirt should remain, right? Should stay the same, right? So the material of the shirt cannot change, because then your experiment would not reflect the true thing. We're changing the color of the shirts. That's what we're changing. All right. So the material of the shirt would stay the same, right? We'd be changing the colors of the shirt. Now, the last thing, how do we go about determining which one is the hottest and which one is the coldest, or the range, or how do you determine this the sequence of the hottest to the coldest? How do you go about doing that? What do you think? I'm just throwing out some ideas out there, right? How would you determine that?
Freezer.
All right, go ahead. Let me hear what you have.
Repeat.
Oh, right. So, after you have placed the shirts in the sun for, I don't know how long you want to place them in there for, say 3 days, 3 days and 5 minutes, right? It's entirely up to you, right? After you place them in the sun for 3 days and 5 minutes, how would you determine which one is the hottest?
Rubbing them close tightly together and using a thermometer.
All right, so one person said that you could wrap them close together, wrap the entire shirt, wrap the entire shirt very closely, and then use a thermometer to measure that, or to place the thermometer inside the shirt. All right, that could be a way. Anything else? Anything else you can brainstorm and think about? A way to determine which one is hottest or which one is the coldest?
But it depends on the type of the color of shirt, sir. I think if you have a black color,
Mm-hmm.
you'll absorb more heat.
Exactly,
White.
but I'm asking, how would you determine that it has more heat? What would you do?
Yeah, use the white skin, feel the skin.
All right, so
Right.
you could put it against your skin, right?
Yeah.
Yeah, you could put it against your skin and determine which one is hottest or coldest. So one person could put their hand on it, right? Hand on the white one, right? You put a hand on the green one, then the orange one, they put the red one and the black one, and you see which one is the hottest, right? That could be a way as well. Anything else? So we talk about using the thermometer, and we talk about using your hands. Anything else?
I think, sir. I think.
All right. All right, so for the interest of time, you can use if you don't want to use those, you can also go ahead and
Thermometer could I use?
yeah, we discussed about the thermometer a while ago by wrapping the shirt tightly and then placing the thermometer inside, right? You can also brainstorm if you don't want to use those ideas or you want to be unique, you can brainstorm some ideas. But for the let me say no. For the you could also what about trying on the shirts, right? You could also try on the shirts to see. You could also try on the shirts to see which one is the hottest or coldest. So it is up to you to choose which one of these is the best one. Which one of these is the best one? All right.
So
No, what again?
that one accurate, sir.
By trying on the shirts, why?
Sure, that all of them would not actually feel the same.
They would feel the same. All right. As I said, it's up to you to choose the best one. All right. Someone might have a different idea, but I personally don't have a specific one to choose. It is your lab. You plan it and you determine which one is the best way. All right. Now for the hypothesis, this is a very important one. We're not finished here, right? We're going to go ahead now and and determine the hypothesis. Now, in your hypothesis, as we said, it's a prediction of your of the solution. Now, the hypothesis, it is an if statement. It should start with an if. So you would say if, right? You would start out with if. You start out if and say something like, if the shirts are placed in the sun, right? then you would go ahead and state the sequence of which one would be the hottest or the coldest. Let me say that again. The hypothesis is an if statement. Most likely it will start with an if. So you'd say the if, then the method, how you plan to carry out the experiment, and then the last one. Go again.
Method.
Yeah. So we're taking it one step at a time, right? We're just dealing with the hypothesis first. So if, then we talk about the method, and then finally we talk about the prediction, right? So this is your hypothesis, or I can add in one more and say the if the problem statement is true. If problem statement is true. All right, so this is your hypothesis. This is how it should be like. This is how I recommend it to be like. So you start out with if. All right, hypothesis. So if the shirts are placed in the water as a method, right, the sequence for the hottest to the coldest shirt will be, and then you would finally say that, therefore, the boy, right, makes a true claim, or he is correct, right? So let me say that again. If all the shirts, right, this is a hypothesis, you're making a prediction of the solution. It's an if statement, so you start with an if, right? The shirts are placed inside the sun for X amount of time. Remember, you choose that amount of time, right? You choose the amount of time. The sequence of the shirt is, or the hottest shirt would be so and so. The hottest shirt could be orange, green, red, right? It's your prediction. It could be anything. It's your prediction. You're testing this now. So it doesn't have to be completely correct. But you're making a prediction and saying that. Then the orange shirt would be the hottest, then the green shirt, then the white shirt, then the red shirt, then the black shirt. It is up to you. Would be the hottest. Therefore, the boy is correct, or therefore, the boy is incorrect, right?
So, sir, we'll put everything correct or incorrect in a hypothesis.
Right. You would say that you're testing to see if he is correct or he is not correct. Are you testing to see if the sequence is correct or the sequence is
home
incorrect?
based lab, sir.
Go again?
Was we at home?
Yeah, this is a home-based lab. So I will need, let me hear an example. All right, how much time we have left? Oh, we're over time. All right, so I need an example of a hypothesis, right? I'll throw it out in the group for Saturday class to discuss the labs on Saturday. All right, so I'll throw it out in the group now. Let's see how they react to it. We're over time. All the best, everyone. I will upload this as always on Google Classroom as soon as possible. If I forget, remember that I'm not teaching only grade 11s. I'm teaching grade 7, 9, 10, 11, 12. All right, so if I forget to upload the videos or the slides, please remind me. All right, all the best, everyone. All right. All the best.